Okay, welcome back to another lesson of explaining physics questions. We have the 2019 independent physics paper, question 23, worth 7 marks in total. Now, let's just read through what each question wants us to do and we'll discuss how to approach them. So, question A, it says derive an equation of orbital velocity orbiting a mass planet at a radius of r. Okay, so we've got that. B, it says show that the total energy of orbiting a satellite is half gravitational potential. So we want to show that this is basically energy total equals to half gravitational. And in question C, it says explain the gravitational potential energy of orbiting us, or explain why it is a negative value. So if we just quickly recall, gravitational potential energy is given as this formula here. So our question is, why is that a negative value? That's what we need to look at. Okay, so let's have a look firstly at the first one. It says derive an equation for the orbital velocity. If you picture, you have a big planet and you have a moon orbiting around it. Okay, going across like that, swirling around. The only reason why that planet is moving in assumption a circular orbit is because there is a gravitational attraction force pulling it in, and there is some kind of velocity going to the tangent of that circle. So we know that the reason why an object is in orbit, okay, is because of gravity. And we know that the pathway we see is circular, so centripetal force. So what we can say is the centripetal force equals to our gravitational force. The equation we are going to use for gravitational force is the one derived by Isaac Newton. All right, that and that. If we move everything over to make v the subject, that would tell us the tangential velocity of the object as it orbits around. So if I move it around, I get v equals to gm. This m and this little m cancel each other out. When I move this, or when it moves over, when I move this little r over to this side, that will also cancel out with this one. So I'm left with gm over r. If I simplify that further, I'll find that v equals to the square root of gm over r, and that is your orbital velocity there. The next one is to show that the total energy of an orbit is half the gravitational potential. So the total energy of an orbit is its gravitational potential plus its kinetic energy. Gravitational potential is negative gm little m over r plus gm m over 2r there. I can work it out, expand it out like that. But what you can see is you need to make the same denominators, or make denominators equal to each other. So you have 2g m 2r plus gm m over 2r, and you find that the total energy is just negative gm over 2r there. And so what we can see is this value here is exactly half the amount of the gravitational potential, which is this value here. So therefore, energy total is just equal to half u over 2. Okay, so I'll leave that one there. The next one is to explain why gravitational potential is a negative value. So we know that, you can write it as GPE or U. I kind of write it in both ways. So there's that. So one, we know the first reason is the 0 point So the reason why we define it as a negative value, firstly, is the 0 point has changed, right? Changed in space where radius is equal to infinity, our gravitational potential will be equal to 0. And also, an additional point, 0 point is no longer on the Earth. Okay? The second point is to drag an object. So if you imagine you have an object really, really far away like that, that's our 0 point, and we kind of pull it closer here, okay? We've essentially done work in the same direction as the gravitational field. So doing work in the same direction as the gravitational field, you can assume it to be, negative work, because everything we've defined up till now has been, particularly gravitational potential on the Earth's surface, has been considered as positive work. So positive work to lift it from the surface into orbit, from orbit, linking it closer to us, negative work. So dragging the object from the 0 point to a distance closer and done with gravitational field, which is the opposite. So that's the opposite to the definition, or opposite to the, let's say, it's the opposite of the initial definition, UGMGH, where that was work done against gravity, Okay, so there's that. A little additional way you can sort of explain it is if you're going from a 0 point and you're dragging it closer and closer towards Earth, that gravitational potential, if it's going from a really far orbit to a low orbit, it's gaining kinetic energy and losing gravitational potential. So an additional point, by dragging object closer to Earth, you are losing gravitational potential, hence negative value. So that's how I like to interpret it. I like to interpret it either as it's work being done by the gravitational field, so that's why we see it as a negative value. Or you can think of it as the gravitational potential energy as you take it from point 0 closer to whatever point of the planet. It's losing gravitational potential and gaining kinetic energy. Either way, both answers would be fine. I like to say it's just work being done by the gravitational field. All right, and so that is that for the question. Just a quick note, if we just have a look at the marking criteria, it says 2 marks if you equate the gravitational force and centrifugal force to provide the velocity equation, so we got that there. Provides the kinetic energy, potential energy, and total energy formulae using their velocity from part A correctly. So, that's fine. And question 23 identifies zero gravitational energy position and relates the negative value to changes in potential and kinetic energy, moving to or away from the Earth. That's 3 there as well.